Hello. Okay, now I should see the desktop now, and you should hear me. So, okay. Okay, still more people that arrive. Everybody hear me? Does that seem okay? See the desktop and you hear me?
Yeah.
Yeah.
Okay. All right. Okay. Okay. So, the second test is today, and we can go over more problems today. So, we'll go over as many problems as we want today on the review problems. Do that first. And the exam's set up the same way as it was last time. You go to Brightspace, you download the exam, and you can either print the exam out, write your answers on the exam, and then scan it back in, or you could write your answers on blank sheets of paper and then scan those. But if you write your answers on blank sheets of paper, please put the problems on the same page they would otherwise be on. So like problem 3 is on page 2, put it on the second page. Don't just write all your answers on one page, because then it becomes really hard for me to find problems. So keep the pages the same. So if you can't print out the exam and you're going to write your answers on blank sheets, I think it's problem 1 and 2 on the first page, problems 2 and 3 on the second page. So keep them on the same pages, and that helps a lot with trying to find the answers. Okay, and keep them in the right order. Yeah, and please keep them in the right order. Okay, so you can either print the exam and write your answers on the exam and then scan it back in, or you could write them on blank sheets of paper and scan them back in. And if you know how to create Word documents or Google Docs, you could always write your answers into a Word document or a Google document and convert that to PDF. Then you don't have to scan it. So if you can write your answers into a Word document, then there's no need to scan it. You can just save it as a PDF and upload it back to Brightspace. If you do something like that, please try to, if you could, copy and paste the problem from the original exam into your answer sheet, because that makes it a lot easier to find the answers again. Like if you can copy and paste the problem into your document. Okay, so that's a couple different ways to do it. Okay, anybody got any question about the exam itself, about doing the exam? Any kind of question that come up about that?
We have until midnight again.
Yeah. Yeah. Uh, yeah. It says right. Yeah, and it says it up on the and it says it on Brightspace too. You'll see on Brightspace that the time is set to be due at midnight. Okay. 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 Now, let's look at the review problems. Is there any review problem that anyone's come up with? Any problem that people have a question about? Now, now's a good time to look at solutions to more of these problems.
Could you go over 10 and 11 and
Hmm.
kind of explain what they're asking?
Okay. Okay. Now, you have to figure out what goes in these spots. Now, uh, remember that here's our words about methods. A method definition has this declaration line, which gives you the name of the method, what it returns, well, what the name of the method, its parameters, and its return type. That's the first line of a method. Then you have the body of the method, which can have local variables and a return statement. Okay, and if you look at some of these other problems, you see examples of that. Like here is a method. It doesn't have any parameters and returns void, but you can see, and then there's the body of the method. Okay. Uh, Here's another example. Here's a method called isMillionaire. Takes in a parameter that's an int, and it returns Boolean. And there's the body. Okay. So now those problems there, the parts are missing. Like for example, what goes in that slot? what's missing there?
Integer, well, or double, sorry,
Okay, what's called, what's the name of the thing that goes there?
the return type.
Your return type, yeah. So that one, and this one too, it's missing the return type. Okay, so yeah, they're missing what the return type is. Okay, now there's a return statement. This one, if you look, there's no return statement, but that would probably be what goes there. Oh, there's a return statement there, and that would probably be another return statement, because you have an if statement, and then you return this, and you have to figure out what that is, or you return this other thing. Okay, so the idea is to fill in the blanks. Like, what goes in that slot? What do we call what goes in that slot?
The parameters.
Well, there's the parameter. So this is what?
The type of parameter.
The type. Yeah, the type. So if you go up here to the words, every parameter has a type and a name. See, method parameters, each parameter has a type and a name. Okay, and if you look at some of the other examples, you see, like in this one, oh, there's a method, there's a parameter with type int, there's a parameter with type int, there's a parameter with type int. See, it's got a name and a type. So over here in the one with the blanks, well, there's a parameter, so it'd be missing its type there. This is a type, so what goes after the type?
Parameter.
Yeah, the name of the parameter. Okay, so, okay, now this is going to be the max of two numbers. One of them's an int, so what's a good guess for the other one? Oh, let me copy this into the Java Visualizer so we could fill in the blank. I can't fill them in here. I can't type into a web page, but if I go to the Java Visualizer, I can type in that code into the visualizer and then start filling in blanks. Okay. Okay. Okay, this thing is going to have, it's going to find the maximum of two numbers. One of the numbers is an int. So what's a good guess for this?
Int.
Int also. But if the two inputs are ints, and you find the max, what would be the type of their max?
Int.
Int, because you got two ints in, one of them is the answer, so its type is going to be int. Okay, what's a good name for this variable?
B.
Pardon me?
B.
Well, we've already used a here. You can't have the same you can't have this, you can't use the same name for two different variables, because then you wouldn't know what a is. It's like if you had twins, you wouldn't give them both the same name. You know, which one is Bob if you call them both Bob? Okay, so you have two parameters. This one's called a, so what would be a good name for this one?
I think she said B.
Oh, I'm sorry, say B? Did you say B? Okay, because, and what's the reason for calling it B? Where's the hint that you should call it B?
In the else statement.
Right, in the else statement, they use a B, so that B had to come from somewhere, and this is the only place where you could declare a B. So you take the hint that that B should be there, okay? So now we got a method that takes in an int that's called A, takes in an int that's called B, and returns an int, okay? Now, here you're gonna return something, otherwise, well, what are you gonna do with the B? You have to return something in the other case also. If you return something in this case, there's really no other choice here but to return something in the other case. Oh, but here you're saying that the answer is B. Okay, if now what would make the answer B? Now notice here you're comparing two things. So the logical guess is that you're going to compare the A and the B here somehow, and that if this is true, probably you want to return A, and if this is false, you would return the B down here, because the B was already here. What would you put here to make A, the true case, and B, the false case. And remember, you're trying to get the maximum of them. So what would you do here to make true being A is the max and false that B is the max?
If A is greater than or equal to B.
Yeah, if A is greater than or equal to B, well, if that's true, A is the bigger. If that's true, A is the bigger. And if that's false, B is the bigger. Because if it's not the case that A is greater than B, it has to be the other way around. Then B has to be greater than A. So B is true. Okay, and now we've gotten all the blanks done, and we can check what's the int x equal max of, say, 2 and 5. Oh, max 2, max of 2 numbers. Okay, and this should work now. So compile, and if we go to the end, we saw, yeah, it got the max of 2 and 5 was 5. So it gave us the right answer. You could try another one. What's the max of, say, 7 and 5? Last, oh, yep, we got the 7. We got the right answer. Yeah, you can do some checks. Okay. Now notice that the way you do this problem is you have to, it's like putting together a puzzle. You know, you've got some pieces of information, you're missing other pieces of information. It helps to know how these things are put together. A method definition starts with a method declaration. The method declaration has to tell you the name, the parameters, and the return type. Each parameter has a type and a name. And then there's the body, and the body better have return statements in it. You don't have to have local variables, but you do have to have a return statement. So then, you know, you go to this problem and you start saying, well, you know, some of it's educated guessing. You know, you guess that if you're going to take the maximum of 2 numbers and one of them is an int. I mean, you could make the case that you could make a double here. You actually could put double there. If you put double there, you can make this work, but then you have to return a double. Because if you have the max of a double and an int, the answer is going to be double. Okay, so you can make, you know, but that'd be kind of odd, be taking the max of a double and an int. So you kind of just, you just assume that it's, you know, what makes the most sense. It would be 2 ints. Okay, now what about this one here? It's almost the same. It wants the minimum. And it kind of changes where some of the blanks are. Okay, the minimum of, oh, well, look, this one's a double. So what should this one be?
Double.
Yeah, you might as well, yeah, you don't, it's not given that if one of the parameters is a double, the other one has to be a double. But since it's the minimum of 2 numbers, you kind of assume that in this case, they probably want the 2 to be the same. So let me open up the visualizer so we can replace the things in this one also. Okay. Okay, so one of the inputs is a double, so assume that the other input is a double. And then if you take the max or the minimum of 2 doubles, the answer is going to be a double. If we call this one A, we have to give this one a name. And since there's a B down here, just like before, we assume that, well, that B must be this parameter, okay? And there's a B here used too. So since there's a B there and a B there, well, let's assume that that's the B, okay? Because we're comparing it to A, so that it makes sense that we will compare the A and the B if we want to find the min. Now, what's this guy?
Local variable.
A local variable. See, you know, you can have a local variable. What the idea is that this local variable is going to hold the answer or the result. So it's going to be a variable that's going to hold which one of these is the minimum. Well, what's the type of that variable?
Double.
And why? Why would you think double?
Because this method is gonna return a double.
Yeah, the method, we decided already that the method will return double, and here we're returning result. Notice here we're returning result. So result all have the same type as what we're returning, which is double. So it makes sense to make this one. Notice you're putting clues together. There's not like, you don't just go from top to bottom and fill in the blanks. You really got to read the whole thing and use a piece here and a piece there as clues to what to put into one of the blank pieces. Okay, so since we're returning result and we decided that the minimum of 2 doubles is a double, this thing should be a double. Okay, now notice that we got a Boolean statement. If it's true, result is this. Otherwise, result is the other number. Well, depending on this Boolean, if one time the result is something and the other time the result is B, what do you think goes here?
A.
A, because one of them is the right number. One of them is the min. And here you're saying that if something, the min is A, otherwise the min is B. Okay, so let's suppose I put A there. Now, what would make this, okay, now what would make it so that true means A is the min, and what would make it so that false here means that B is the min? So just concentrate on this one. You want this, when it's true, to be that A is the minimum, the smaller of them.
Less than 0.
Less than 0, because how do you get a negative number when you subtract? If I subtract A and the B, what makes that subtraction negative?
If A is smaller than B.
Yeah, if A is smaller than B, and that's exactly what we want. If A is smaller than B, that means we want the result to be A. So we want this to be a negative number when A is smaller than B. Okay, so A minus B less than 0 means that A is the smaller, but if it's not true, then it's the other way around, so B is the smaller. Okay, all right, actually, and we filled in all the blanks now, so we can kind of go here, int x equal min 2 of, say, 3 and 5.
Should it be double?
Oh, I'm sorry, you're right. It's double this time. And I can put decimal places here. I can make that 3.2 and 5.6, 5.5, because they're doubles now. Okay, so now, oh, and if I left it int, if I had left it int, I would get a error. See, I can't return a double and put the answer in an int. So the compiler would have warned me about that. Yeah, if this guy's returning a double, it won't fit in an int, because what do you do with the decimal place? Yeah, so we think of it as not fitting in the int because this thing has a decimal place in the answer. There's no room here for the decimal place. Okay, so this was supposed to be double. Okay, and then you can just check. Okay, the min of 3.2 and 5.5 is 3.2. Here's what if you make this negative and negative, which is the min now? Which
Negative
number?
5.5.
Yeah, because it's farther left on the number line. Minimum really means who's on the left on the number line. So negative 5.5 is to the left of negative 3.2 on the number line. So now negative 5.5 is smaller than negative 3.2, but 3.2 is smaller than 5.2. So, yeah, and it makes sense because what min is really asking is which number is on the left of the two of them. Yeah, if you plot those numbers on the number line, which one's on the left? Okay, so another way, if one number is negative and one number is positive, yeah. Now the negative number, of course, is to the left of the positive number. So again, the minimum is going to be the negative number. Okay, all right. So the problems were to fill in the blanks using two things. One, using the vocabulary of how a method definition looks. A method definition starts with the line that's the declaration. It has the name, the parameters, and the return type. Each parameter has to have a type and a name. Then the body of the method has return statements. Okay, so that's, yeah, you have to use those words. You have to think in terms of those ideas. And then down here, you use clues. You know, like if let me show you how I could, if I don't do this carefully, I can give you a problem that's not really doable. Okay, now, now you're just really wildly guessing. Okay, what is it you're guessing about now? This would be a very bad exam problem.
About what type? it's
Yeah,
supposed-
because what's missing? You don't know the type of this input. You don't know the type of this input. And you don't know the type of the return value. So you just have to make a wild guess, like, oh, let's just make them all double. Let's make them all int or something like that. So no, yeah, you have to, if too many blanks are in there, you really won't know what's going on. If I made that a blank, you'd be real hard pressed to kind of guess what was supposed to go there. A minus B, you might guess, well, I might be comparing it greater than 0, less than 0. So if there's too many blanks, the problems aren't doable. So in the case of this homework, you assume that there's enough information in here that you can, it's like a jigsaw puzzle. There's enough information that you could figure out what some of the other blanks are. If there were too many blanks, then you would be in trouble. So you're going to use the fact that, oh, well, this one's a double. So then I would guess that this one should be the same. But if those are both doubles, it has to return double. I could have, for example, made this one double. That would be kind of a hint that the two inputs should be double too. Okay, so if you got that piece of information, that would be a hint that you can make this one double and this one double, though it would not be wrong to put int there. It would work. It'd be an awfully weird method to take in two ints and return a double, but Java would actually let it work. It would work okay that way. So if somebody put double here and ask you what goes here and what goes here, well, you could say that you could put double or int there, but you probably want double. But you could put double or int there. And even when this problem has double there, it means you have to put double there, but you could put double or int there and it'll work. Because you can compare an int to a double. But your return answer is going to have to be a double. Okay? All right. So that's how these problems work. Use the idea of how a method is declared, return type, name, parameter. The parameter has a type and a name, a type and a name. So you use that structure to know, okay, well, this has got to be a type. This isn't going to be a name. That has to be a type. This isn't going to be a type. It has to be a name. This one's got to be a type. And then you go in and you start thinking about how much information have you been given? How can you make guesses about what would go here and here? Okay. All right. Okay. What about other problems? Let's do another one. Let's do other ones from here.
Could we look at number 17?
Sure. Where am I? Okay. Let me copy it. Put it up in the visualizer. Okay. Okay, you got a method. And the idea, there's that's the one that's given to you. Now here's one we want to edit. We want to make it shorter. The problem was to find a way to make this guy shorter. So the way problem said is the body of the following method has 3 statements. Okay, 1, 2, 3. 1, 2, 1, 2. There's an if. There's a variable declaration, an if statement, all in one line, and a return statement. So there's 3 lines of code there. So it has 3 lines of code. Rewrite the body so it has just a single line of code, a single statement. Okay, yeah, so we have to compress all that down to just one statement. And the hint is, when does the method return? Notice it's a Boolean method, so it returns either true or false. Because it's like, think about when does it return true and when does it return false. So let's go over here and look at it. Okay, here's the, okay, so I'm going to delete all this because this is the one we want to rewrite. Okay, and then we want to look at this one to give us a sense of what to do here. Okay, so is inside. Okay, the names, okay, we're supposed to be thinking inside of something. Then we take a number, and there's something, the notion of it's inside of something. We start by saying inside is false. That's a guess. We're guessing that our answer, see, this is inside is the thing we're returning. We're going to return this thing. We have this variable called inside. It's a local variable, and we're going to return it. So right now we're guessing that, well, it's not inside. We're going to guess false. Then we say if 0 is less than n and n is less than 100, then inside is true. So what is this thing inside of?
It's between 0 and 100.
Yeah, it's inside the range from 0 to 100. Okay, so that's all this thing is doing. It's saying, you're asking, is this number inside the range from 0 to 100? Okay, so you guess, no, you guess false. You just make a guess. You say, no, I think it's not. Then you check, well, is it greater than 0 and less than 100? Well, then you say, okay, yeah, it is. So you say true, then you return true. Okay, that's how this works. Now, think about how this is saying. If this thing is true, you return true. See, you're going to return inside. So if this thing is true, you're going to return true. On the other hand, if this thing is false, you're going to return false because you're not going to do this. So inside holds false. So now you listen real carefully to what I'm saying. If this thing is true, return true. If this thing is false, return false. So let me see what was kind of being said there. If this thing is true, return true. If this thing is false, return false. When this thing is true, return true. When this thing is false, return false. Can we see the shortcut? When this thing is true, return true. When this thing is false, return false.
I mean, it functions like an if-else statement, but I don't know how to do it so it's a single line.
Well, okay. Don't forget the if else. Just listen to the, it's in the words. If this thing that's highlighted, if that thing is actually true, so it is true, return true. When that thing is false, return false. What am I returning?
A Boolean value.
Yes, but more specifically, what Boolean value am I returning? When that thing is true, I return true. When that thing is false, I return false.
So you're returning the thing.
Yes, that's exactly the right answer. I'm returning the thing. I'm returning the thing. That's the answer. Kind of weird, isn't it? That's the answer. I'm returning the thing. Because when the thing is true, I return true. When the thing is false, I return false. I'm always returning that thing. This is one of the big stumbling blocks in programming. When you can start, it becomes natural for you to see this and say it's this. This is a real common problem because it's something we want you guys to eventually all see easily, and it takes effort. Okay, it's a weird kind of thing, but here's another example. Let me rewrite this one a third way. Here's another way to write this method, because you've mentioned it's acting like an if-else statement. So let me actually write it like an if-else statement, and you'll see what you mean. You were right about saying it's like an if-else statement. Okay, so now I'm almost saying the exact same thing. If this is true, return true. If this turns out to be false, return false. Notice I read, that's the same thing as I said over here. Here I said inside, I'm always returning inside. So whatever is inside is what I'm returning. So inside starts out false, but sometimes I make it true. Well, if this thing is true, inside is true, so I'm returning true. If this thing is false, then I'm returning what was originally an inside, which is false. Here's a slightly more direct way to write this one, okay? And here it's clear. If this is true, return true. But if this thing's true and this is true, if this is, then they're the same thing. On your hand, if this is false, return false. But that means this guy and this guy are the same thing. So I'm always returning this thing here. I'm returning that thing. So that's the right way to write it. So as programmers, what we're trying to hopefully, over time, you start seeing this as a verbose way to write this. And you start seeing this as a verbose way to write this. If this is true, yeah, return true. You won't write it this way anymore, saying, well, if this thing's true. Oh, let me show you even a worse way to write this. Here's something you'll see programmers write every once in a while. And if you write this in a job, your boss is not going to be happy at all. If this thing is true, return true, else return false. Here I'm being really overly verbose. I'm saying that if this thing is true, return true. Otherwise, return false. That's still correct, but notice I'm even typing. I'm kind of. I don't need to ask, is this thing equal to true? Because that's exactly what the if statement does. When this thing is true, you go to this branch. But you'll see even every once in a while an experienced programmer will accidentally kind of write down, they're thinking, well, when this thing is true, I want to do something. So they'll write if blah, blah, blah equals true. Well, the equals true is redundant, but it's not wrong to write it there. But even this whole thing, all this is redundant. If this is true, return true, otherwise return false. It can be just made into that one line. Okay, so here's three kind of verbose ways of saying this real simple thing. Return the fact that n is greater than 0 and less than 100. That's either true or false. When it's true, you're inside. When it's false, you're not inside. Okay. So it's getting used to the idea that this thing is an expression that has a value, and you can just return. Here I'm basically, that's what I'm interested in. I'm totally interested in the result of this expression. That's what I mean by inside. So I don't need to say it in this verbose way of guessing that the inside is false. checking this expression, changing the value of inside, then returning inside. That's a lot more work than I needed to. Or, well, check if you're inside. If you're inside, return true. Otherwise, return false. Well, that's kind of redundant. I don't need to do it. Yeah, I can just return this guy here like this. Okay. Right. So it's kind of a quirky little thing of getting used to. It's a matter of abstract thinking. You know, these are more concrete. This feels more right at first. This feels more right. Even this kind of feels more right. But after a while, you realize, but no, this is the real, that's the really precise, super concise, accurate way of saying that inside is that. Inside is n is greater than 0 and n is less than 100. Okay? Okay, all right. So what about another one from any of these? What about another one from any of those?
Number 18, I was also unsure on like how far to simplify, I guess.
It's a lot like 17. It's a matter of trying to figure out where there's like a redundancy that's not at all obvious. Like here, it took a little bit of effort to see that this was actually redundant stuff and that this is actually redundant stuff. So it's a little bit hard. So let's do that one. Let me put it in the visualizer so then we can start. So I'll put it in once. That's the original. Then here's the one we can work on. I'll put it in again. And on the second time, we'll try to figure out how to make it, how to streamline it. Okay, now let's concentrate up here. Let's just read it first. Okay, no, okay, in the interval is, okay, so it's asking, it says in the interval. Now notice it doesn't return Boolean, it returns int. So we'll see what it's called in the interval, and it takes in an integer. Okay, now if n is less than 0, it returns a -1. Now here's a summary. If n is between 0 and 1, if n is greater than or equal to 0 and n is less than or equal to 1, then it returns 0. And if n is strictly greater than 1, it returns 1. Okay. Now notice what it's really saying is -1 and 1 are not in the interval, and the interval is this here between 0 and 1. So 0, the return value of 0 kind of means yes, in the interval. And the -1 means no, you're on the left of the interval. And the +1 means you're on the right of the interval. That's actually not an uncommon trick in programming to use -1, 0, and 1 to mean not like a Boolean answer just means yes or no. This is an answer that says yes, but there's two no's. There's like a no on the left and a no on the right. And that comes up a lot. A good example of that is alphabetical order. You could be equal to something, or you could be less than it, or you could be greater than it. So it's not uncommon to have a three-way answer, not just a Boolean answer. And a lot of times when we want three-way answers, we do that -1, 0, 1. Okay, so here the idea is -1 means you're to the left of what we call the interval, which is between 0 and 1. +1 is going to be to the right of that interval, and 0 is you're in the interval. Okay, now let's start looking. Now, what does it mean here? We never get here.
If it's a positive, so if it's on the left, it's automatically going to return -1. If it's within the interval, it's going to return 0. And if it's above it, it's going to return 1. So
and
we
there's no
never
fourth
actually
case.
get there.
Yeah, so you got this thing checks for three cases, right? We call them three mutually exclusive cases: on the left, in the middle, and on the right. There's no fourth case. So you can never get down here. Okay? So you would never get down there. Now, here's something interesting. Let me comment out this one because we haven't done it yet. If you never get there, delete it. Okay? Now, compile it. And Java doesn't like you. Missing return statement. Okay. it wanted that return statement there, even though we never got to it. We just agreed that we never got to it. We've got three mutually exclusive cases. You're either to the left, you're in the middle, or you're to the right. Nothing's left over. So you can never get down to the last case. Now, here's what's happening. The compiler says, well, this thing could be false. So if this thing's false, you skip over that and you go here. This thing could be false. If this is false, you skip over that and go here. Now, the compiler is dumber than we are, and it says, this thing could be false. Now, we know it can't be, but the compiler is not that smart. But the compiler says, this thing could be false, so you skip over that. What's wrong?
Get rid of the else if, make it an else.
You should, yeah, well, no, what's the compiler's point of view? This thing could be false, skip that. This thing could be false, skip that. This thing could be false, skip that. What's the compiler complaining about now?
It thinks there's going to be a fourth case.
Yeah, the compiler is positive now there's a fourth case and you didn't give a return statement for it. Because the compiler doesn't understand the logic entirely, and the compiler thinks, well, the way you wrote it is, this thing could be false, this thing could be false, this thing could be false. There's a fourth case, and you didn't give me a return statement for it. So it says, missing return statement. Now, we can see it better than the compiler can, and so we know that there is no fourth case. But now you said the answer was to do what now? If there really isn't a fourth case, there's really only three cases. How do I kind of fix that?
I would personally change the order you have things, but do an if, else if, and an else.
Yeah.
But if you made, yeah.
Well, okay, I kill that, right?
Mm-hmm.
See, so now first case, second case, the third case is the default case. Now the compile. Now if this one's false, you do this. If this one's false, you do this with no condition. So if you're not in this case, not in this case, you have to be in this case. The compiler's happy. Okay. Now you're right. This may not be in the best order, but at least now see that we made the compiler happy by not having to have that third test there. Okay. Okay. So now as we've simplified, now it's compared to what actually this is what we started with. Why are we simpler so far?
Because the computer doesn't have to check all three if, else if statements.
Yeah, it doesn't have to make three tests. What else have we done that's better now? Why are you happier with this so far than this? One thing is there's only two things to check here. There was three things to check here. So good, yeah. So now what else is making this one better? One other thing.
I mean, it's shorter.
Yeah, because you did what? You got rid of
That return 42.
Yeah, you got rid of the kind of silly redundant line of code that didn't need to be there, shouldn't have really been there. So we've gotten rid of that silly kind of redundant line of code. That's an improvement. Because a programmer look at this and go, why would you say return 42? We never got here. I mean, delete it and the compiler complains. Put it back, but you never, so there's something really not good about that line. So we've seen how to get rid of it. We got rid of a superfluous test case, because if you're not in this case and you're not in this case, okay, you're in that case. All right. So by getting rid of the superfluous test case, we could also then get rid of superfluous extra line. Okay. Now, okay, what else can we do maybe to make this better? Okay, you said change the order. How would you make the order different?
You get rid of the and statement, and then you would switch your return values between that and the bottom one, because if you make your second else if statement n is greater than 1, we know that it's automatically going to be on the right hand side, and so then you have your else statement as everything else, because it would have to be between 0 and 1.
Yeah, so that's a nice way to make things all a little bit easier to read. So first you check on the left, then you check on the right? Oops, I'm sorry. And if you're on the right, the answer is 1. Now, what's left? If you're not on the left and you're not on the right, where are you?
In the interval.
In the middle. Yeah. And notice that the code's a little bit shorter. Yeah. So we made it even a little bit, maybe, yeah. Now some people might find this easier to read, and some people say, well, wait, this is shorter, so it's better. You've got less code written here. They mean the same thing. It was important is we haven't changed the meaning of it. On the left means strictly less than 0. On the right means, oh, I made a mistake here. This should have been what? What's on the right?
1.
Yeah, strictly greater than 1. See, you make changes. If you're not careful, you do introduce bugs. So yeah, it was meant to be the same thing, but I had a bug in it. Now, yeah, now I see the on the left is strictly less than 0. On the right is strictly greater than 1. If I'm not on the left or on the right, my default case is I'm in the middle, which is in the interval. That's 0. So now this one's a nice shorter version of that one, which is it's an even shorter version of this thing. Okay. I don't think you can make it any simpler than that. So that would be the best answer. Okay. Now let me show you another in-between answer, a little bit better than this one, but not as good as this one. So here's another answer that's kind of in between them. Okay. So we're going to go from like best, well, good, better, best. Okay. So here's going to be better than this one. The middle is written as n is greater than 0 and n is less than or equal to 1. Okay, now think, 0 and 1 are 2 integers next to each other. This is an int. What's kind of funny about that?
It would have to equal 0 or 1.
Yeah, there's nothing in between them. So you can simplify this to say n is 0 or n is 1. So there's a little bit simpler way to write it. It's a little easier to read. Yeah, this and these inequalities were red herrings. This is not really an interval because these are ints. So the only thing greater than or equal to 0 and less than or equal to 1 are 0 and 1. They're the only thing in the interval. They're the only ints in the interval between 0 and 1. So this thing could have been simplified a little bit to that. That's a little bit simpler. N is 0 or n is 1. But then moving it out, like I said, moving it into the default case makes it even easier, even less to type. You're either on the left, you're on the right. So you could even make a nice comment here. On the left, this case is on the right. And then the default case is in the middle or in the interval. Okay, so that makes it real. Now all of these are equivalent. Now, as a programmer, you can say, well, it doesn't really matter which of them you use. They all do the same thing. And that's important. They all do. All 4 of these now do the same thing. Okay, but okay, what do you think as a boss? What do you think I'm going to tell you is what I'm worried about? They all do the same thing.
You want it to be easy for the computer to get through. So like the first one we started with had unnecessary tasks for the computer to do. And then you
Exactly.
want it to be readable for
Yeah.
someone else.
And actually, one of the hardest things about programming is which of those 2 is more important. Right now, we're doing both. We're making it less work for the computer, and we're making it easier to read. This answer down here is less work for the computer to do, and a little bit easier for us to read. Quite often, those 2 are not mutual, they're mutually exclusive. Sometimes to make it easier on the computer, you have to make it harder to read. To make it easier to read, you have to make it harder on the computer. In the real world, if you have a choice between making it easier on the computer or easier to read, which do you think they might prefer?
The computer.
Why?
Because you're dealing with big chunks of code and you don't want it to take that much work if it has to run through tons and tons of cases and numbers.
Yeah, if you're going to do this test a billion times, then you would say, I really want it to be less work on the computer. But suppose this test is only going to be done a few times, maybe once a day. Then you might say, I'd rather it be easier to read. So the answer tends to be, how often are you going to do this chunk of code? If that chunk of code is going to be executed billions and billions of times a second, then you actually start saying it better be as easy on the computer as possible. But if it's a chunk of code that's only executed once every few minutes, which is actually, most computer code doesn't get executed all that often. So in the real world, more often than not, if you have to pick one between readable or easier on the computer, usually you pick readable. Readability is usually considered the higher priority. Readability is usually the higher priority. But then you end up with chunks of code that are literally executed billions and billions and billions of times a second. And then you start saying, readability, to heck with that. Let's make it as fast as possible. And you end up writing, sometimes people write impossible to read code. There's lots of famous examples of code that's just utterly impossible to read, but it's super fast. And you just tread on it very carefully. And that doesn't happen very often. But every once in a while, readability is the least important thing because the code is just being executed so often. So here we got both. This one's easier because there's less things to check. Instead of checking 1, 2, 3 if statements, we only check 2. There's simpler if statements. See here, we only check 2, but it's a more complicated if statement. So we've definitely got it here to be easy to read and less work. So that's the best answer. Okay. And notice notice I gave you 4 answers. Yeah, so you began to say like you weren't sure how much to change it. And the answer is yeah, you wouldn't know without experience. Without experience, you start. That's why we do these problems, is to start showing you how I can take this ugly code and keep making it better, make it a little bit better, make it a little bit better more, make it a little bit better still. We even have a fancy word for making it a little bit better, a little bit better, a little bit better. People tend to call it refactoring. So you look at refactoring is a disciplined technique for restructuring existing body of code. Altering its internal structure without changing its external behavior. Essentially what they're saying is making the code better. Refactoring is when you take code and you don't change what it does. You want it to still do the same thing, but you want the code to either be faster or easier to read. So that's what we just did. We did an exercise in refactoring. We started with this guy, refactored it once, a little bit better, finally got it to be the best. Okay, and there's even a word for that. There's whole books written about this idea of refactoring. Here you're seeing a baby example of it, and then people do this on thousands of lines of code. There's ways to do this stuff on large chunks of code. But this is the beginning, like a simple example like this. This code does what we want it to do, but not very well. It does what we want it to do. It doesn't do it very well. Makes too many tests, and it's hard to read. It's kind of awkward to read. So we improved it. Okay. All right. How about another one?
Can you do number 9?
Okay. Let's see. Okay, let me start up with put it in the visualizer. Now this is not a method. Notice it's an if statement. So I'll put it in the main method now. See, now I can put it inside the main method of the visualizer because it's not a method on its own. It's a little chunk of, it's essentially an if statement. Let me indent it right. All right. Now, the question is, what does this thing do? The problem was, okay, let's look at the words of the problem. Explain what the following program does. So that's our first job. Just what is it doing? Okay. Then here's the funny thing. Then add a pair of braces. Notice there's no braces. Now, if statements should probably have braces in them. They're not required to have braces, but the rule is you ought to always have braces. There's no braces here, and our job is to put the braces in there. But there's a funny thing here. So that the resulting code prints out what is always correct. There's a hint there that this thing is going to sometimes not be correct. So let's go look at the code. Notice it prints out either x and y are both 0, or it prints out x and y are not equal. And the hint is that sometimes it doesn't print out the right thing. So let's look at what happens here. If this thing is true, we go into here. If this thing is false, what do we do?
Can you say that again?
If we got an if statement, there's a Boolean. If this thing is true, what do we do?
We go down
Check.
into our next if-else statement.
Right. We go down to this whole if-else statement. That's what's inside the true part. What if this thing is false?
Skips
It
all.
doesn't return anything.
Yeah, it doesn't return anything. No, it doesn't print anything. See, it's not a method, so there's not a return value. So if these are equal, it prints out something. If these are not equal, it doesn't print anything. But wait a minute, if they're not equal, why would we possibly print out they're not equal? See, there's something kind of fishy there. If these things are not equal, we don't print out anything. Okay, now go down in here. Suppose they are equal. And then if this is true, so they're equal, x is 0. So what does that tell you? Is
That
that
y
a
is
true
0.
statement? Pardon me?
That y is also 0.
So is that a true statement when it's printing out?
Yes.
So if they're equal and x is 0, well, that means that y is 0 and they're both 0. Okay, so that's okay. Now, suppose this is true and this is false. So x and y are the same number, but x is not 0. What do we do?
Right now it's going to print x and y are not equal.
But we know what?
They are. So
They
we
are
need to
equal.
do
So that's
nothing.
see, so what this thing does is it prints out x and y are both 0 when x and y are both 0. And it erroneously prints out x and y are not equal when they're equal but not 0. When they're equal, like if they're both 5, if x and y are both 5, this will be true, this will be false, and you'll print out x and y are not equal. So it correctly prints out x and y are both 0 when they're both 0, and it incorrectly prints out x and y are not equal when they are equal but not 0. And what does it do when they're not equal?
It skips everything.
Skip doesn't print out anything. Okay. So now the question is, how can we adjust this so that when it prints something, it always prints a true statement? How do we get this thing to be true? So this guy's the one that's a problem.
You
Put the
put-
brackets after the first if statement and
Yeah, you
or
want
before
to,
the first if statement.
yeah, because you want to attach this if, this guy should be attached to what?
The first if statement.
Yeah, the first if statement. So we can fix that by putting bracket there, bracket there. See, now this guy is attached to this guy because the true part of him is this, and this is the false part of him. If this is false, x and y are not equal. If this is true and x equals 0, x and y are both 0. Now there's still a missing output, but what's the missing output?
if they're equal but not 0.
Yeah,
But then
but it-
you know it if it prints nothing.
Yeah, but see, now I'm never printing the wrong thing. When it prints this, it's correct. And when it prints this, it's correct. And when it doesn't print anything, I know that that meant that X and Y were equal, but they weren't 0. Okay, so the answer was that brace there and that brace there. That put the else attached to this if. Now, if I wanted to, I should also change the indentation, but the indentation doesn't really matter in Java, but it would be nice to change the indentation so it read a little better. Okay, but the more important thing is the braces. The braces are what broke that else away from this if and attached that else to this if. Notice that that's kind of a quirky thing. What this is saying is you have to be very careful who your else's are attached to. This is another reason why we say you should always put braces in if statements. You can get, this is called the dangling else problem. It's even got, everything's got a name. The dangling else problem, it's got a Wikipedia page also attached to it. Okay, it's actually a fairly common problem in programming. If you don't put braces in your if statements, you can really mess things up by accident. You can really make a big mistake by forgetting your braces. Okay, so this is actually called the dangling else problem. I wanted that else actually up on this if, but I got the else attached to that if because I forgot the braces. And as far as Java is concerned, indentation doesn't matter. So the fact that now, if this was Python, the alignment would make this, it would be, in Python, this else is attached to this if because they have the same indentation. In Python, to attach this else to this if, you out-indent it, you outdent it. And you don't use braces, you just put the indentation in line with the if. So if the else is in line with the if, then it belongs to the if. So in Python, you would shift this thing out to here, and that would fix the problem. In Java, if you leave out the braces, this is why this is actually a big problem. If you leave out the braces here in Java and just have the indentation like this, it doesn't do what you think it's doing. You know, you think this else is attached to this if, and it isn't in Java because you're missing the braces. In Python, this is attached to this. In Java, this is attached to this. Because Java prefers that you put braces, but doesn't require the braces, so you can end up with very mixed up code. And it's a common enough problem. It even has a Wikipedia page just about it. Okay, the kinds of grief you can get when you goof up if statements, nested if statements, and don't get the braces right. Okay, so if I want this to make sense in Java, I need to say, I should actually always put my braces in if statements. So for example, I really should put another pair of braces there. They're not required, but there's good Java. Every if statement, and actually good Java would say I should even put the braces there. Okay, now that's good Java. I put all the braces that I put all the braces in. With if statements, the rule of thumb is put all the braces in there. You're not required to, but put them all in there. It's way safer. Many companies require it. You know, they analyze code using automated programs, and one of the things they check for are all the braces there in the if statements. And if an if statement's missing braces, it gets flagged, and somebody has to go add the braces. Even if it's correct, it gets flagged as missing braces, and somebody has to go in there and put the braces in. So in case a programmer forgot, even if it's not wrong, the rule of thumb would be, they check for it, all if statements and else statements should have their braces. Okay, so this is a classic little problem. You see this problem in lots of books, you see it everywhere. That's a classic little problem of what can go wrong, how things can get goofy if you don't be careful about the braces. Okay, all right. What about another problem? Got time for at least another one.
Someone asked about 6.
Oh yeah, I forgot. I keep forgetting to look at the chat. Okay. I think. Oh, okay. Let me go ahead. if I put it in the Java visualizer, we can actually do it. Oh. Oh, I'm sorry. I should just erase everything in this box and put our problem in there. Okay, and then I need to comment that out so the Java visualizer doesn't complain about it. Okay, there's the out. We want that output. Okay. Oh, oh, got the. Oh, I'm sorry. When you have these comments, you can't put stars and. Oh no. Okay. Yeah. Now it's all right. Yeah. It finally woke up. Okay. Yeah. When you put stars inside of comments, you can get goofy things. It's it's a minor little problem in Java that comments are /star, and if you put stars in the comments, things can get goofy. Like if I should put a slash there, that's all of a sudden the end of the comment. Yeah. So stars and slashes end up being goofy and cause problems in comments. This was a kind of a mistake in the design of the language. Okay, so you gotta be careful if your comments have any stars or slashes in them. Okay, so that's what we want out. Okay, we've got we're given a method A that prints 1, 2, 3, 4, 5. We're given a method B that prints those stars, and those look a lot like that. Okay, so that's essentially method B. And here's print those. That's actually this. Okay, so now what goes in here's the main. We're supposed to put what in. We're supposed to write code in the main that gets that output by using these as efficiently as possible. Okay, so kind of the easy part so far is that we're going to start with method A. No, method. Which one do we start with?
C.
This method C. Yeah. So method C gives us our beginning. Some stuff goes in between. Method A gives us the method. The ending is method B. And this one's not spelled right. Okay. What now? The real interesting part is what would go between them? How am I going to get this? Now, if I run this, I should be okay. This should compile, and it should run. Okay, see, there's the beginning, there's the end. I still need this part in the middle. Okay, so I need something in the middle. Notice I test. When you're working on code, you test as much as possible. Okay, now what am I going to do to get this?
We can
Could
make
you
a
write
for
a
loop.
small for loop?
Yeah, because method A will print this stuff for me. So I could just type method A, method A, method A, method A, method A, method A, but that's going to be 0 points. Yeah, the idea is you're not supposed to write method A, method A, method A, method A. How many times do I need it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I think 14 of them, right? I think I needed 14 of them. Okay, so now, you're going to get 0 points for typing method A 14 times. So you're supposed to use a for loop to avoid repeating something like that. So int I equals 1. I want to count to 14. I less than or equal to 14. I plus plus. What do I put inside my for loop?
Method A.
Yeah. Now,
But
method.
then you need.
Oh, yeah. Now, method A does the printing for me. Okay, so method A will do the printing. It'll print 1, 2, 3, 4, 5. But I also need something else. What?
You have to print the dash
Yeah, I have to print that myself. So after calling method, now does it come before or after method A?
after.
After. So right after method A, I'll do a system.out.print. Now, should I do print or print line?
Just
Print.
print.
Print because
It's all in one line.
it's all in one line. Yeah, I don't want to break the line. It's all in one line. So here's the minus sign. Okay. So let method A do its share of the work, then add the minus sign and do that 14 times. Am I done?
No.
What's left?
After the for loop, you should print a line.
Yeah, because the for loop leaves me off right there. But I really want to be after the for loop, I want to go back to the beginning of the next line. Okay, so let's try it. Let's go ahead and run it, see what it does. Go to the end. Seems okay, but no, look, see how I got something over here that wasn't supposed to be there. See, it kind of looked okay, but you have to look kind of carefully and say, well, wait a minute, there's something tacked on to the end there. This shouldn't have been there. Okay, so you got to look carefully to see if there's a problem. And that's fixable by, before calling method B, do a system.out.println. That print line will end this long line and get us ready for the calling of method B. Okay, now check it. Go to the end. Go look at our output. Okay, notice how that star now lines up with that star. They weren't lined up before. Those stars weren't lined up. And if you look at the end, see, it ends the right way. Okay, so that the problem is just asking you to look at the code. It's not a hard problem. It's saying, look at what the output should be, look at what's given, and just think of how do you piece these together? How do you piece these together in an efficient way to get that output? And the main thing it's looking for is you don't call method A 14 times. You don't write method A, method A, method A, method A, method A, method A, method A. Okay, that would be a real big mistake. So, that's where for loops are there for. The whole point of for loop is to do something that needs to be done over and over and over again. Okay, we're done. It's end of class. So the test, you can go to Brightspace. You can download the test now. If you have, I don't know if I mentioned at the beginning. If you have questions during the test, you can send me email. Especially if you're unsure, if you think there's something goofy in the test, if you think there's something that might be a mistake, or you're afraid you might be misinterpreting something, send me an email. Okay. So you have everybody's supposed to do their own work, but you certainly have the right to ask a question, as many questions as you want during the test by email. I'll try to answer them. My wife is still a bit sick. I'm hoping I'll be here this evening. But if there's an emergency, I may. If you send a question and you don't get an answer, it's probably because there was a little bit of an emergency. So I may be gone for a while. So, but if you do have a question, send an email and I'll try to answer it. Okay. And otherwise, have it. We'll meet again on Tuesday and have a nice weekend. And like I say, if you have questions during the exam, send me an email with the questions. Any last question here before we quit? No? Okay. If there's no other question, I'll go ahead and I'll end the meeting. And okay, see you next Tuesday. Bye.